Okay, everyone, taking a look at 4.8 today, functions and relations on page 256. Got a couple goals. We're identifying when a relation is a function, and we're using function notation to represent real life situations. Got a couple vocabulary words first. First one's relation. Relation is any set of ordered pairs. So you're talking about a set of values when you're plugging in an x and y value. So it's like an input-output machine like we've been working on. Set of values would be like -1, 0, and 1. When you plug those values into the equation given, let's say it's 3, 7, and 9 when you as your values. That is a relation. -1 is related to 3 in that equation. 0 is related to 7. 1 is related to 9. Function notation is a way to name a function that's defined by an equation. On our example for homework last night, we had a couple of questions at the end where they gave us 3 different lines. One of them was blue, one of them was red, and one of them was like green. It was called black for right now. Instead of saying line A, line B, and line C, you could have said, you could have named each of those lines. Like blue could have been H, um, X could have been G, and the black one could have been F. So when you're working each of those equations, it could be F of X, it could be G of X, and it could be H of X. All you need to know about function notation is that it represents Y. Each of those, it's like Y equals whatever the equation is when you work it. But you read it as F of X, you read it as G of X, and you read it as H of X. Graph of functions, it's the set of all points like X and F of X. Notice it says F and then F of X, where Y would normally be, where X is the domain. So X, your X values, those are your domain, or each of those is your domain. Y is considered the range. X is the domain, Y is the range. So when you're looking again at an XY input output chart, these are your domains right here. And this is your range. Domain and range. Example number 1 says identifying function to decide whether the relation is a function. When you're looking at function mapping like this, you have an input output bubbles, if you will. A lot of times people just circle them like this, each of those. When you're looking at that in order to determine if it's a function or not, when you're looking at your inputs, when you're looking at your domains, those are your domains, the numbers can only have one arrow leaving each of them. Notice number 1 is you check them. Number 1's good. It only got one arrow. 2's good. 3's good. They each have one arrow. When you look at number 4, though, it has 2 arrows leaving it. That's why that one is not a function. It's not a function. Input 4 has 2 outputs, 6 and 8. That means when you would work that equation, when you'd plug the number 4 in place of x, you're not going to get 2 different values. You only get one. That's why it's not a function. Whereas when you look at the second one, when you look at b, each of the values 1, 2, 3, and 4, they only have one arrow apiece leaving them. But then you ask yourself, well, what about number 9? It has 2 arrows coming into it. That's okay. The outputs, when you're talking about the ranges, if they have 2 of them coming into them, it's okay. You just need to make sure when you're looking at your function mapping that your inputs or your domain, each of them only has one arrow leaving them apiece. Okay, the first checkpoint's deciding whether each relation is a function or not. The first one, as you check your domains, remember input's the same thing as domains. Each of those values only has one arrow apiece leaving it. Therefore, this one is a function, yes. It says, if so, give the domain and give the range. So your domain is 1, 2, 3, and 4. That's your domain. And what's in the function mapping in the input part. Your range is 5. It's what's in the output part. So give the domain and the range. Domain 1, 2, 3, 4. Range is 5. As you look at the second one, 1, 3, and 4 are good. They each have one arrow leaving them a piece. But as you look at the number 2 inside of your domain or inside of your input here, it wouldn't be a domain. Inside of your input, it has 2 values leaving it. It has 2 output values. Therefore, it is not a function. Vertical line test is a whole lot easier for most people to understand, especially when they're looking at pictures. A relation is a function of the horizontal x-axis. Remember, the horizontal is the one that goes across the road. If and only if no vertical line passes through two or more points. Once it passes through 2 points, it's no longer considered a function. So when we're testing each one of these, we're going to take a look at all of them. We're going to determine if they're functions or not. The first one, this is the vertical line they have drawn for you to determine if it only crosses through the function one time. The way I was taught to do it, I was taught to just draw a whole bunch of vertical lines through it. And you could count. Your graph only passes through it one time through that line, once through that one, once through that one. It only is passing through them one time a piece, therefore it is a function. Other people learn to put pencils on it and do it that way. That's another way you can do it. Lay your pencil down on it. You can check this one the same way. Draw yourself a bunch of vertical lines. Remember, vertical go this way, and count how many times the graph crosses through it. It crosses through it once right there, once right there, once right there, once right there. That's why it's okay. It is a function. When you draw your lines on this next one, however, you can see you only need to do it one time. You don't even need to prove it more than once, but it crosses through this graph one time. It crosses through 2 times right there. It does the same thing with all the rest of your vertical lines. That's why that one's not a function. And the same thing for this one. As you draw your lines through it, it crosses through more than one time. Right here, it crosses through 3 times, but that doesn't matter. More than 2 times or 2 or more times is what matters. Therefore, that's why it's not a function. So the vertical line test is very simple. First two are functions, the second two are not. When you're evaluating the functions, notice the little bubble says you don't have to use f to name a function. You can use letters like g and h. Mentioned that earlier. The first one, f of x, says negative 3x when x equals 2. Negative 3x when x equals 2. First thing you want to do is you want to rewrite the function as f of 2 because x's value is 2. Notice we just plugged in 2 in place of that. Remember, that's what we consider y anyways. And we plug in 2 in place of this x. So everywhere you see an x, you're going to substitute in 2. And when you simplify negative 3 times 2, you get negative 6. So f of 2 equals negative 6. The second equation, g of x equals 4x plus 20 when x is negative 3. Again, in place of x, not g, in place of x, you're going to plug in negative 3. So that's what we're going to do. We're going to substitute it in. In place of g of x becomes g of negative 3, and 4 times x becomes 4 times negative 3. Substituting in negative 3. So g of negative 3, 4 times negative 3 is negative 12, and negative 12 plus 20 is positive 8. So g of negative 3 is a positive 8. The second checkpoint says evaluate the functions f of x equals 11x plus 3 when x is negative 3. So what you're going to have is f of negative 3 equals 11 times negative 3 plus 3. 11 times negative 3 is negative 33, plus 3 is negative 30 for that one. So f of, this is how you need to write it, f of negative 3 equals negative 30. Don't just write negative 30. F of negative 3 equals negative 30. The second one, you'd rewrite it f of x equals 6 minus 1.75x. You'd rewrite it as f of 10 equals 6 minus 1.75 times 10. Anytime you multiply anything by 10, it just makes you move that decimal over one time. So 1.75 becomes 17.5. So a lot easier to deal with in that form. 17.5. So what you have 17.5 being subtracted from 6 is what f of 10 is. So that's a positive 6 and a negative 17.5. So subtract them. 17.5 minus 6 is 11.5. And since negative 17.5 is farther from 0, f of 10 equals negative 11.5. Example number 3 is graphing a linear function. Graph f of x equals 3 over 4x minus 2. This is just like we did graphing with the y-intercept form. Y equals mx plus b. This is still m. This is still b. This is just what we consider y right here, f of x. Notice it says to do that first. Rewrite it as y equals 3 over 4x minus 2. Your x-intercept is negative 2. Again, that's your b value, so that tells you where to start your graph. 3 over 4 is your slope. That's your m value. 3 tells you to go up 3 times. 4 tells you to go to the right 4 times. So when you graph this equation, you want to start your value at b tells you where to start. Its value is negative 2. That's where we're going to start. Ignore this picture right now. Ignore how they have the red drawn. I don't like the way they have it drawn. But from our point, from -2, we need to go up 3 times. So up once, twice, 3 times. And then to the right 4 times. 1, 2, 3, 4. That's where your second point goes. And then you draw your line just like the picture they have. Again, slope tells you to go up 3 times and to the right 4 times since they're both positive. And then the last checkpoint, f of x equals -2x plus 1, graphing the function. So y equals -2x plus 1. When we look at that one, plus 1, it'll still be mx plus b. mx plus b. B tells you to start at +1. M's value is -2. M equals -2. Remember, every number is considered to be over 1. That helps when you're talking about your slope. Tells you to go down 2 times and to the right 1 time. So from the point 1, from that point we just made, go down twice and to the right 1 time for your second point. Once you have 2 points, you can draw your line straight through just like the picture. For the second one, f of x equals 4x minus 3. Again, y equals mx plus b. M is your m value is 4. Your b value is -3. So we're going to start at -3. That's your point you're going to start at. B always tells you where to start. M's value is 4. Every number is considered to be over 1. 4 tells you to go up 4 times and to the right 1 time. So from the point where you start, go up 1, 2, 3, 4, and go to the right 1 time to put your second point. Once you have 2 points, you can draw your line straight through to both of them. Up 4 times and to the right once.